From today onwards, we are going to start the new branch of physics, that is kinematics. And under this kinematics chapter, we are going to cover three sub chapters. And you can say kinematics is basically a branch of physics in which we study about the motion of particles and the rest and motion of particles. And these kinematics branch is again subdivided into three chapters. The three chapters are, the first one is rectilinear motion or 1D motion or motion in straight line. The second chapter is projectile motion, and the third chapter is relative motion. Okay, let me write our first chapter name. First, the kinematics branch. Kinematics is branch in physics. Okay, these kinematics is divided into three chapters. You can say sub chapters or whatever it may be. It's your wish. మీరు ఏమైనా చెప్పచ్చు. మీరు సబ్ చాప్టర్స్ అనుకోండి, లేకపోతే చాప్టర్స్ అనుకోండి, వాట్ ఎవర్ ఇట్ మే బి. ఫస్ట్ చాప్టర్ ఈస్ వన్ డైమెన్షనల్ మోషన్, or it is also known as rectilinear motion, or it is also known as, okay, let me tell the another name further. And the second chapter is projectile motion. Projectile motion. And the third chapter we are going to study is relative motion. Relative motion. These are the three chapters that we want to study in the upcoming days. Okay, moving on to the first chapter. Let me pick the light blue color and moving on to the first chapter. The first chapter is rectilinear motion. You can also say it as one dimensional motion, 1D motion. Or you can also say it as motion in a straight line. Okay, you can call the first chapter by these three names. Okay, don't confuse if they are going to say rectilinear motion, that means motion in straight line. That simply means motion in straight line. Or 1D motion means also is one dimensional motion. That means in one direction the motion gonna happen. And coming to the next thing, we are going to discuss some definitions. Some definitions. Okay, the first one is, we are today in this class we are going to study about the two definitions and get a good command by solving the good problems. And that two definitions are uh, distance and displacement. Most of the people think that these are very basic. We can solve any type of problems from distance and displacement. Let's see how it goes. Keep following me, and you at last you have the sensational and you can say very good questions. I'm going to increase the level. This is the first question, and this is the second question, and this is the third question, and this is the fourth question, and this is the fifth question. So please stay tuned till the end until we gonna solve the problems after discussing the concept of distance and displacement. Okay, the definitions. The first thing, the first and the foremost definition. Let me pick the purple color. The first definition is displacement. Okay, what is displacement? What is displacement? Displacement is nothing but the shortest distance. The shortest distance is known as displacement. That's it. And what type of quantity it is? It is a vector quantity. Vector quantity. Okay. And what are the units of this displacement? The units of this displacement are the units of length, right? It is nothing but distance. Distance nothing but length. Uh, Meter, kilometer, centimeter, micrometer, whatever it may be. That is the displacement units. And if I wanna say it is a vector quantity, then what is the direction of that vector quantity? That means it has both magnitude and direction. Okay, okay. Let me show how you can plot this. Let me pick pink color, and suppose there is a particle. There is a particle at point A. It is the initial position of that particle, initial position IP, and it traveled somewhat like this, and this is point B. Okay, let me write it neatly. Uh, Let me use the space here. This is point A, and this is the initial position of the particle. And suppose it traveled like this, and it ended up here. The particle final position, and we need to study about the displacement. Displacement is nothing but it's a very simple. The straight line joining the initial path and the straight line joining the initial point and the final point. Just it's a straight line. Just it's a straight line. It's a straight line joining the initial and the final point. Okay, this is displacement. It is a vector quantity denoted by S bar, and the direction is towards from initial point to towards final point. This is the direction. What is the direction? Direction equal to from initial point to final point. And what is the magnitude? As we discussed, vector quantity has both magnitude and also it has direction. We already discussed about the direction. It is from initial point to final point. And what is the magnitude? Magnitude is nothing but length, or you can say shortest straight line length. Sorry, let me erase this and write. It's a straight line length. It will be more accurate. It's a straight line length joining initial point and final point. Okay, that is the displacement vector. And the second thing that we are going to discuss before discussing the second thing, and we need to discuss let more further about the displacement. That is, suppose there is a body. Let me pick the pink color. There is a body at this. There is a particle at this point A, and it traveled and it ended up here. This is point B, and what is the displacement vector? The displacement vector is a straight line joining the initial and the final point. Okay, this is the displacement vector, and the direction is towards the final point from initial point. This is the magnitude. Okay, this is the displacement magnitude and direction. Okay, I think you understood this. And moving on to the next uh, detailed concept, that is something more about the distance. Suppose there is a particle at point A, this is the initial position, and there is a particle at point B, this is the uh, final position, and suppose it travel like this, and we need to find out the distance and the displacement. Suppose it travel like this, and this is the displacement, right? This is the displacement. Okay, this is the displacement S vector. And suppose if I take the coordinate axis over here, I take the coordinate axis over here. This is x-axis and this is y-axis. This is the origin. This is a frame of reference. Suppose a person is sitting at the origin and is observing everything, and this is the frame of reference. The straight line joining the straight line joining this is r initial vector, and the straight line joining this is r final vector. I need to discuss the vector law of addition over here. ఇక్కడ ఏ విధంగా అంటే ఇక్కడ ఈ రెండు ఫాలో అవుతాను, ఆర్ఐ ఆర్ఐ వెక్టర్ మరియు ఎస్ వెక్టర్ ఫాలో అవుతాను. దానికి ఆపోజిట్ వచ్చి ఆర్ ఫైనల్ వెక్టర్ డాష్ ఇచ్చింది. అంటే మనం ఏం రాయొచ్చు అంటే ఆర్ ఫైనల్ వెక్టర్ కెన్ బి ఈక్వల్ టు సారీ ఆర్ ఫైనల్ వెక్టర్ మస్ట్ బి ఈక్వల్ టు ఆర్ ఇనిషియల్ వెక్టర్ plus S vector. If I find the S vector is R final vector minus R initial vector. This is, I will write over here, S vector is nothing but R final vector minus R initial vector. Okay. And suppose this as a coordinates x1, y1, z1. Suppose this point A as a coordinates x1, y1, z1, and point B as a coordinates x2, y2, z2. Then the displacement can be written as displacement equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay, that is the displacement vector. That's all. Let us take some examples and understand through examples. Suppose this is x-axis. This is x-axis, and there is a person over here, and initially is at uh, initially is at 4 meter position, and finally is at 10-meter position. What is the displacement? The displacement is nothing but the vector joining the initial position to the final position. It's a straight line joining the initial position to the final position. This is S vector. Okay, and if I calculate the if I calculate the mm, displacement, let me write over here. This is x final minus x initial. That means displacement is plus 6. Plus 6 denotes the displacement here is x final vector minus x initial vector. This is equal to x final is 10 plus 10 minus plus 4. This is equal to plus 6. Here plus denotes uh, positive x-axis direction, and 6 denotes magnitude. If they are taken in meter, you can write here meter. If they are taken in kilometer, you need to write here kilometer, whatever it means. Okay, and taking the second example, taking the second example, suppose let's take x-axis, and the final position is 4, and the initial position is initially it started at 10 meter, and it reached here. What is the direction? It is from initial position to the final position. Straight line joining the initial position to the final position. This is the direction. Okay, this is the direction of displacement. Okay, what is this S vector? S vector is x2 minus x1 I cap, or you can say S vector is R final minus R initial. R final minus R initial. Since the person traveled only along the x-axis, we write x final minus x initial. This is plus 4 minus plus 10. This is equal to minus 6. Here minus denotes the direction, and this denotes the magnitude. Okay. This denotes the magnitude. Minus denotes the direction. Here this minus denotes the direction, that is negative x-axis. I want to write here towards negative x-axis. And this is magnitude. Okay, yes. 6 is the magnitude, and this minus denotes the direction, that is towards negative x-axis. This is the displacement. And if I talk about the second definition, that is distance traveled. So many people use it to say it as uh, just distance, but the correct meaning arises only if we talk about the word distance traveled. Okay, the second definition here is distance travel. Distance traveled is nothing but what? It's very simple. Distance traveled is nothing but the actual length traveled. The actual length traveled. Suppose this is point A and this is point B. If it is travel like this, and if we take a thread and measure this distance, and take a thread and measure this distance, take and measure this distance is known as distance traveled. Okay, that's it. And if I talk about the type of quantity, it's a scalar quantity, scalar quantity, and it has only magnitude. And the units are, it is also length, right? So units are meter, kilometer, centimeter, micrometer. These are the units. Okay, and the last concept that we are going to discuss, that is very important. Distance cannot be negative. Can be zero. When it can be zero? Suppose there is a bench over here. Suppose there is a bench over here, and a bottle, is kept on this bench. And if you observe from time t equal to 0 second to time t equal to 10 seconds, its distance is distance traveled. It's not distance, it's distance traveled. Distance traveled is equal to 0. That's it. But it cannot be negative. It can be 0, or that means the distance traveled value can be 0, and it may be, it might be positive. It might be 0 or it might be positive, but it cannot be negative. That is the one most important thing we need to remember. And the second thing is uh, magnitude of displacement is less than or equal to distance travel. It is also very simple. And the last important point is when a particle reaches to its initial position, then displacement is equal to 0. That's it. That is the third thing. And now moving on to solving the problems. In this question, they said that a particle started at A and it traveled to B, and it again traveled to C, and it traveled to D, and it traveled to E. Then what is the displacement, right? Displacement is nothing but the straight line joining the initial point and the final point, and the direction is towards the final point. But here they didn't ask the direction, but they only asked the magnitude of the displacement. That means we only need to say the length of the shortest distance. That means from A to B, the value gonna be like this. This is the displacement, and we need to calculate this value. Since this is r, the value is root 2 r. And distance traveled. The displacement is the magnitude of displacement is root 2r, and the distance traveled is, since the total circumference of the circle is 2 pi r and it is equally distributed into 4 parts, 2 pi r by 4, which is pi r by 2. This is pi r by 2. And from A to C, this is root 2r and this is r. Root 2r, sorry, it comes under, this is A to C. A to C is nothing but this thing. In straight line joining the initial and the final point, and the direction is towards the final point. And this magnitude is nothing but r. And distance traveled, distance traveled from A to C is nothing but, from A it is pi r by 2 and this is r. Pi r by 2 plus r. And from A to D, this is 2r. And this is from A to D, this is nothing but uh, pi r by 2 plus 2r. A to E. A to E is again root 2r. A to E is again root 2r. And this thing, distance is nothing but A to E. A to E. This is pi r by 2, this is r, and this is pi r by 2, r, and this is pi r by 2, pi r plus 2r. And from B to E, from B to E, from B to E, the distance is 2r. Again, it is 2r. And the displacement traveled is from B to E, r, pi r by 2 plus 2r. Okay, let me write the values clearly over here. Let me take the black pen and let me write the values clearly over here. I will fill the answers from A to B, A to C, A to D, A to E, B to E. A to B, B to, sorry, A to B, from A to B, B, A to C, A to D, A to E, B to E. Okay, yes. Root 2r pi r by 2. The magnitude of the displacement is, and distance traveled. We need to find the, we need to fill up the tables. Root 2r pi r by 2. Root 2r pi r by 2. And this is r pi r by 2 plus r. R pi r by 2 plus r. And this is 2r pi r by 2 plus 2r. 2r pi r by 2 plus 2r. and this is root 2r pi r plus 2r, root 2r pi r plus 2r, and the next thing that gonna be 2r pi r by 2 plus 2r, 2r pi r by 2 plus 2r. Yes, these are the values. Let me write it over here. Pi r by 2, pi r plus 2r. Okay, solving the next problem. We need to calculate the displacement vector and the distance. Distance is so simple. You can easily calculate the distance first of all. You can easily calculate the distance traveled. This is equal to, simply add 4 plus 3, 7, 7 plus 5, 12 meters. That's it. It's very simple. But when you come to the displacement magnitude, most of the students think it is, when we take the magnitude here, uh, it is 5, 5. This is 5 and this is 5. This is total 10 meter, but it is wrong. Why I'm saying it is wrong? Because if, since this angle, this angle is uh, 53 degree and this angle is 37 degree. If this will be 53 degree, then it's gonna work in this case 10 meter, but it is not uh, 53 degree, so it is 37 degree. So the answer is not 10 meter. Then how to solve this type of problems? It's very so simple. Let's take this as, this is the initial position, right? Let's take this as origin. This is origin, 0 0 0 x1 x1 y1 z1, and let's find out the coordinates of D. Now to find out the coordinates of D, you need to know the first and the most important theorem, that is, if this is theta and this is let's say uh, a, the length is a, this will be a cos theta and this will be a sin theta. This is the resolution of vectors. You need to know this much, simple, that's it. This is how we resolute the vectors. Now let us resolute the vector over here. That towards the angle made, it is 5, this length, this length is 5 cos 53 degree, and this length is 5 sin 53 degree. Okay, therefore we get the x coordinate as, since we are talking about the 2D, you can simply remove this, because in 2D we don't take the z axis 0 comma 0, and this is 5 cos 53, 4 plus 3 plus 5 cos 53, x initial equal to 0 comma y initial equal to 0, x final equal to 4 plus 3 plus 5 cos 53, 4 plus 3 plus 5 cos 53. What is cos 53? Cos 53 is nothing but uh, 4 plus, sorry, 4 plus 5 cos 53, not 3, 4 plus 5 cos 53. This Cos 53 is nothing but 3 by 5, which is sine 37, right? Okay, this one be 7. And y final is nothing but it is 3. Height. Height. 3 plus is height. We are taking the height from point A towards the, we are traveling towards the y-axis. Since we have already traveled towards the x-axis, now we are traveling towards the y-axis. This is 7, 5 cos 53. And y final is 3 plus 5 sin 53. 3 plus 5 sin 53. This is equal to 3 plus 5 into sin 53 is nothing but cos 37, which is 4 by 5, which is equal to 7. So I can write it as, we already know the displacement vector is nothing but x2 minus x1 I cap plus y2 minus y1 j cap. Displacement vector equal to 7 minus 0, 7 I cap plus 7 j cap. Therefore, magnitude of the displacement equal to square root of 7 square plus 7 square equal to 7 root 2 meter. This is the magnitude of, therefore, the magnitude of displacement is equal to 7 root 2 meter. Okay, yes, we successfully solved this question also. And moving to the next question. This is one of the good question, and you need to know the geometry to solve this question. First of all, let me solve it in a detailed manner. What is distance? Distance is nothing but it's so simple, right? Since this is an equilateral triangle, sorry to say, sorry to say it in the question, it is an equilateral triangle. Since it is equilateral triangle, it divide AC, A to B, A to C, and B to C into three equal parts. Okay, into three equal parts. That means the value from A to B is nothing but A to B is nothing but 2 pi r by 3. 2 pi r by 3. Okay, yes. From B to D, we need to know the value from B to D. Since it is equilateral triangle, uh, this is, what is this length? This length is r, radius, and this angle is 30 degree. This angle is 30 degree, and this is also r. This angle is also 30 degree. So when we again split this into the component, the horizontal component is r cos 30 degree, and since it is uh, equilateral triangle, this is 2 times r cos 30 degree. B2C is nothing but B2C is nothing but 2 times r cos 30 degree. This is equal to root 3 r. Next, simply from C to D. C to D is nothing but r. C to D is nothing but r. Therefore, I can say the distance is equal to 2 pi r by 3 plus 2r cos 30, sorry, plus root 3 plus 1 into r. Then what about the displacement? I can easily solve the magnitude of displacement from here. The magnitude of displacement is nothing but straight line joining the initial point A and the final point B, right? This is the magnitude of, this is the displacement vector, and this is the magnitude of displacement, which is also r. Okay, we also successfully solved this question. And moving on to the next question. A particle travels east by 20 meter and then it moves towards north and travels 30 meter and moves toward vertically. It is simply take the coordinate axis, take the coordinate axis clearly. This is Z, this is, suppose this is Z, this is X, and this is Y. Okay, since they are saying like this, a particle travels towards east by 20 meter. Since they are saying it as towards east by 20 meter, towards east by 20 meter. Okay, and again towards north by, it is like this. This is 20 meter, and again towards north by 30 meter, and again vertically upward. Vertically upward means towards the Z axis. Okay, this is towards the Y axis. I think you can be able to visualize from this picture. This is north direction. This is X axis, and it is east direction, and it travels 40 meter upward, vertically upward. That means towards the Z axis. So therefore, I can write the displacement vector is this vector, S1 vector plus S2 vector plus S3 vector. S vector equal to S1 vector is 20 I cap plus 30 j cap plus 40 k cap. Just you need to calculate the magnitude. That's it. Magnitude of S vector. This is equal to square root of 20 square plus 30 square plus 40 square. That's it. Square root of 20 square plus 30 square plus 40 square. That is the value of displacement. You only try to calculate the displacement. And moving on to the last question of this session, find displacement and distance traveled from A to B. A to B. A to B. Simply, it's so simple. Find the displacement traveled from A to B. This is the displacement from A to B, and it is the direction. And they are asking the magnitude of the displacement. So we need to find out this length. This is the answer for this. To get this one, since this is 120 degree in 120 degree in regular hexagon, so this angle is 90 degree and this will be 30 degree. Okay, 30 degree. And if I have to say this is L, this is also L. If I break this into component, this is L cos 30 degree, and this is also uh, 30 degree. This is also L cos 30 degree. This length is nothing but L cos 30 degree, and this length is also nothing but L cos 30 degree. Therefore, displacement equal to, therefore, displacement का magnitude equal to 2 times L cos 30 degree equal to root 3 L. This is the final answer. Okay. Uh, if you like the lecture, please like the video. మీకు లెక్చర్ నచ్చితే గన వీడియోని లైక్ చేయండి. అదేవిధంగా ప్లీజ్ షేర్ ఇట్ యువర్ ఫ్రెండ్స్, అండ్ ఆల్సో ప్లీజ్ subscribe to this channel, NGR Institute of Maths and Physics. You are going to get daily 1 or 2 videos regularly, and have a nice day. Have a nice day. Bye bye. Take care, and I will meet you in the next session. Thank you. Thank you very much.